Hello and welcome to our video series talking with leaders in the construction industry about the role of technology in construction. Today we're talking with Mike Sessions. He's the department chair at the College of Design and Construction Management at BYU-Idaho. How are you, Mike?
Good.
Good.
I am going to correct you already.
Yeah, sorry.
That's okay. It's the College of Physical Sciences and Engineering.
Oh.
I'm the department chair of the Design and Construction Management Department within that college.
Okay, it's the College of
Physical Science and Engineering.
Okay, let me do it again.
I'm not the dean of that college, thank
Right, you're just the department chair.
That's it. Just.
Okay, let me do it again. Hold on.
Okay, well, you could have kept all that in. It would have been a little bit.
Yeah, let's just keep it in. We'll keep it fluid and natural. People like to see that.
Okay, the Design and Construction Management Department has about 900 students. So, well,
Wow.
actually, it has a little over 900 students. So
that's amazing. Yeah, because when I first started, I think there was only maybe half of that number.
Yeah, it's really grown.
Yeah, I started the program in 2016 in the spring semester. So, okay. And when I visited Brother Nielsen, who was the old department chair, as you know, in the fall of that year, and he said something about maybe 375 students were in the program. So there was a big jump.
Yeah, there's been a big jump since then. Some of that's due to the VDC degree that we have, because we have 200 students in the VDC degree.
That's amazing. Yeah, and we're going to be talking about that a little bit more today. But before we get into that, why don't you just give us kind of a general outline of your career so far?
Okay. The last 7 years I've been here at BYU-Idaho, and 4 of that I've been the department chair. But before that, I was part owner of a large construction company on the East Coast. We had about 1,200 employees. And most of what I did there, well, about half the time I was the vice president of operations, and about half I was the vice president of administration, or some companies might call it a CFO or something like that. And prior to that, and even during that time, a lot of my construction experience was in the semiconductor industry. So I built either as a project manager, a construction manager, worked on a lot of projects for companies like Intel, Motorola, AMD, Digital Equipment Corporation. Some of those companies don't exist anymore. They've been swallowed up. Micron was one of my very first ones, actually, that I worked for, and they're still around, big entity. So it's actually during that time frame when I was, let's see, about 25 years ago, because of our expertise in clean room construction in the semiconductor market, we were contacted by NASA, and we built a project that was for Kodak, Eastman Kodak, and they were assembling a part of a orbital telescope. So it's up above, it's been launched years ago.
Okay.
And they were doing this jointly with NASA, and NASA wanted a very hyper clean environment to put this telescope in, because they'd had some problems with Hubble, and they wanted to make sure that everything was perfect.
Yeah.
And it was during that time that I first got introduced to something like VDC. We put together a 3-dimensional design and videos of assembling the telescope and erecting it inside of the space that we built. And it was not quite as slick as it is today, you know, to do a good 3D walkthrough, and some just short little movies. The computers we had it would fill a full office. Wow. Some of these computers, and it would take overnight to do all the rendering and assembling the videos. So,
well, what software was it, if you remember? Do you know?
I don't remember. right now, but I think it was software that we had found out about through Bechtel, and
Okay.
they were using it in some nuclear applications. And so it was there, and the promise of doing estimating and scheduling and all that kind of stuff, you know, within a BIM environment was being sold, but it was just so time. It took so much time to get the models built, and they didn't have families. I mean, we didn't have all that kind of stuff. So you had
Right.
to kind of build each part in piece. But that's kind of, you know, a little bit about my background. Was mostly very high tech, semiconductor manufacturing, and with companies like Kodak, we first started seeing the VDC or BIM world begin to really take out. It wasn't the first time BIM had been out there in 3D, but it was the first time that I remember really seeing it put into an application.
Wow, that's really interesting. That's some good insight. Yeah, I haven't been around that long. I remember the first time I ever saw it, I was 15, and I was touring. Well, I had a classmate whose father was an architect. He worked for HOK Sport here in Kansas City, where I live now, and he took me around, you know, in his office, and you know, they had all these beautiful models that they had built and all these plans. He was showing me how they posted RFIs, you know, back in the day with like stick-it notes. And anyway, he took me down to like the basement, the lower level, and that's where they had all the BIM people. And you know, at the time, you know, these people weren't even architects. A lot of them were like software engineers. So I guess this was like 15 years ago. So gosh, it's 2020 now. So this is about 2005, 2006. Anyway, and I remember that was my first time seeing it. It was really primitive back then. You know, I don't know if they were using Revit or something else, but yeah, I mean, it's changed a lot since
It's
those
come a
early.
long, long ways. Yeah,
Yeah.
it sure has.
Well, thanks for the introduction. Yeah, we're gonna talk a lot about the VD&C construction management degree that you mentioned. Could you tell us a little bit about that degree and how it came to be at BYU-Idaho?
Sure. Prior to leaving industry and coming to BYU-Idaho, we were dipping our toes into VDC and 3D models and that kind of stuff for probably 3 or 4 years. So that would have been about 10, 11, 12 years ago that we started using it. And we were really trying to find practical applications. We knew there was something there, but we weren't quite sure how we could use it in a way that was really meaningful for us as a business, as a contractor.
Mm-hmm.
And then I came here and started teaching. And within, you know, a couple of years, we started to hear a lot of contractors talking. Well, I shouldn't say a lot. We started hearing about the really big contractors, construction managers, talking about BIM, and that they were using BIM to help them figure out how to lay out a room, or you know, something like that. It still was not super productive, but for a really big contractor, I remember one came and they were building a premier hospital, and they had a surgical suite for one of the top surgeons in the entire world that they had to build. Well, the surgeon couldn't look at a two-dimensional drawing and conceptualize in his mind how all this would work in surgery. And so they created this 3D model for the surgeon, including he used some robotics in this surgery. And so it included monitors, it included the robotics, some of the handles, the controls that he used, surgery table with, you know, a person mocked up, if you will, in the BIM environment on the table. And then they put on some VR goggles and put this person into a VR suite and allowed the surgeon to kind of go up to the table and act like he was, you know, using the equipment. And that was, you know, that was maybe 5 years ago or something like that, but it was super cutting edge kind of thing, maybe 6. And so as I started to hear these things, I began to realize that there was some really good practical applications for VDC. This might have been a very cutting edge application that not every contractor would use. But as I imagined what he was talking about, I could start to see how there could be a bunch more applications for it.
Mhm.
So we started putting together a VDC degree. We already had an associate's degree in architecture, and we had 4 architects in our department, but we were really still focused, even though it was called architecture, it was still a very practical
Yeah.
degree. So in a lot of ways, it was a degree that students used to get a good introduction into sort of design and construction. And some students would go off and get a master's in architecture, but very few.
Mhm.
We noticed that most of the students would roll into a CM degree,
Mhm.
and they really liked that, some of that hands-on in the CM. And so we modified that. We still have the architecture associate's degree, but we have retooled some of the classes so that they're much more aligned with concepts that I would think of as souped up coordination drawings and spool drawings, some things like that that would still be valid for architecture, but would have more practical application for either architecture or going to a subcontractor or going into a construction manager to do coordination drawings, detailing in the 3D environment. We still teach some things in the architecture associate's degree like Lumion,
Yeah.
because we have students who graduate and go to work for contractors who put together proposals with amazing fly-throughs and walkthroughs of BIM, models and things like that. And so that's still very valid for either direction that a student wants to go, architecture, or if they want to go on the construction side. So as we were building this, we were calling contractors all over the country, trying to find out who was using BIM and what was the reason, what was the application.
Mhm.
And I guess about the time we got it, just about the time we got the degree approved, I took a sabbatical and I went and visited a number of contractors and sat down and watched how they were using it, what they were doing. And this had only been a couple of years from the start to that point. And already I was seeing things that had not come up in the phone calls.
Right.
For example, I remember, let's see, the estimating software, and it just skipped my mind.
Sage? Is it on Sage?
No, it's the one that draws from the Revit model.
Oh, Synchro, maybe?
No,
No, not Synchro. Okay. Yeah.
no, I'll think of it.
Okay.
But anyway, I was sitting there with an estimator, and he's using this software to pull all this data out of the model. And so I said, gosh, guys, we talked to you about this 2 years ago. You never brought this up, that you were even using software to pull estimating data out of a model.
Yeah.
And he looked at me and he said, that's because this software only came available 4 years ago, and 2 years ago, it was still, experimental, and we hadn't even started using it. So we just kind of started incorporating it in the last year and a half or so. And now, it's a thing that a number of us are using to get certain kinds of estimating data right out of the model. So, it's evolving very, very quickly. And when I was out visiting with contractors and seeing how they were using VDC, it was interesting because a lot of things that we thought we would teach our students to do, how it would be applied, was being applied. But there was a number of things like estimating that we didn't even conceive of at the time that were being applied. Assemble, that's the name of the
Yes,
software.
the symbol. Okay, yeah. It's really grown in the past 2 years.
Assemble has just taken off in the last couple of years.
Well, it was acquired by Autodesk, and they're like a behemoth. So I mean, they really helped.
Right. But there's a lot of things like that where you just can tell that we're on the tip of the iceberg of where VDC is going. and contractors all over the country are using certain aspects of it to improve productivity significantly.
Yeah.
And there's just stuff that's still under the water that we're dreaming about, that people are some of the big guys are trying, the smaller outfits aren't doing yet, but within another 3 to 5 years, there's going to be stuff that we just didn't even conceive of, 5 or 10 years ago that are making a huge difference.
Yeah. Yeah.
So, I mean, I could share one of those with you. I know
Sure.
you asked me about the degree, but I was at a job, and I won't talk about who the contractor was, but
Right.
I was at a project, and they were using augmented reality in the field.
Mhm.
As you know, augmented reality is like a set of glasses that you can see through. Whereas
Right.
virtual reality, you're in your own little space. You can't see outside that. It's like being in a movie theater.
Right.
Whereas augmented reality, you're looking through the screen. And so they had the model projecting onto the glasses. And we were out looking at a concrete pour that was going to happen the next day.
Mhm.
And this happened to be a building that had a lot of underground utilities that came up through the slab. So, we're standing in this space. It's going to be a huge concrete pour the next day. And there's all these 4-inch conduits sticking up out of the ground. And the guy's got his augmented reality glasses on, and he's looking around, and he looks over at this pipe, and he's kind of doing this in the air, and he says to the electrical sub, he says, "Hey, that piece of conduit's a foot off." And the
Oh, wow.
electrical sub says, "No way," and so they have this little, how that goes, a little
Yeah.
argument about whether it's right or wrong and who's right. And so they finally go pull a tape. And sure enough, they pulled it exactly 1 foot off, and it was 1 foot off. And what he was doing with his fingers was measuring.
Right.
So he was adjusting in the model, with his fingers like a mouse, what that dimension was. And then he was measuring it, and he knew that it was just about a foot off.
Mhm.
And so after they measured it, they dug it up, they moved the conduit, reburied it before they poured the concrete. Now, in just say 6 months, a year ago, we would have poured that concrete, went into set equipment, found out it was a foot off, or somebody would have done a QA, QC test with, tape measure or something. Somebody would have noticed, and we would have been jackhammering concrete out and redigging up and moving it.
Yeah.
Because this equipment, you can't just move the conduit because you feel like it. The
Right.
equipment's got to go in a certain spot.
Right.
Conduit's got to be there. So, there's things like that are happening all over the place that I saw. I went to another site, and they were using augmented reality to hang the ductwork. So the guy wasn't even getting out a tape measure to
Wow.
decide where the ductwork goes. He had somebody on the ground with augmented reality, and he looked up, and he go, it's right there. And there's a couple of guys on the lift, and they're cranking things up, and they're getting within, better than an inch tolerance.
That's amazing. Yeah, I mean, with those mechanical, electrical, plumbing systems, I mean, it's you've got so many things you have to install, and it's hard to take things off with a tape measure because your frame of reference is usually a wall. Well, when you're in a giant space, it's really hard to figure out where you are in relation to. I mean, when I was an electrician, we ended up just kind of going for it, right? A lot of the times we would just wing it, but like you said, things end up going wrong, and you're out of the job site the last month working 80 hours a week just trying to fix everything that you messed up at the beginning of the project. So
Right. Well,
yeah.
and because we now have the 3-dimensional models, we're packing more stuff into smaller space.
Mm-hmm.
So, in a hallway with a dropped ceiling or a lowered ceiling, I mean, we're just trying to jam everything in there.
Right.
And our VDC engineers are designing it so we can fit everything in there. But, now you have to think about who goes first, and you really have to think about who gets in that space. And you almost need to use the model in some cases to get things where you really need to go. You can measure, but the way we're moving things around, it becomes very difficult. It's not impossible, but in the old days, we left ourselves a lot more room. I
Mm-hmm.
can remember, building a semiconductor project, and below where the production level was, there's a big area for mechanical equipment. All the piping and everything comes up from beneath. Well, the way we did is that we said, okay, electrician, you have this elevation of space. As long as you run everything in that elevation, you're fine. And mechanical, you have everything in this elevation of space, and sprinkler fitters, you have everything in this. So everybody had kind of like, in airplanes, they all have to fly at certain elevations so they don't run into each other.
Right.
Well, we did that too. Here's your aisleway that you get to run your electrical tray, and here's your elevation. And as long as you're in those spaces, you just get in and go and blow. I mean, in some ways it was simpler, but now we're just trying to get things tight and packed in, and you're in there with everybody else in that
Yeah.
same space now.
Right. Right. Exactly. Yeah. I mean, I was an electrician on campus at BYU-Idaho, and that was a major point of contention usually on job sites, because at BYU-Idaho it's very much still kind of the old way of doing things. So we'd all get together at a building. It was usually the snow building, right? It's an older building, where they do music. And I remember my supervisor getting into arguments with the carpenter and the HVAC guy, everybody about where things go, who goes first, who could work where, and BIM solves a lot of those problems over the computer. I've been in a lot of BIM coordination meetings, and there's still these heated discussions, but it's happening months and months before the project starts. And
Right.
another point I wanted to make was that, I think in the construction industry in general, we're seeing a push more towards prefabrication, right? And that's only possible because of BIM. If you can't see it in a model, you can't prefabricate it. And this augmented reality that you're talking about, when you have prefabricated elements, it's really important to put them in the right space, because I worked on a couple projects when I was with a larger electrical company several years ago, where almost all of our projects were prefabricated, and all the pieces would come pre-assembled in like a Connex box or several Connex boxes. And we would spend whole weeks just looking over the plans, trying to figure out where all these prefabricated pieces went. And so there's a lot of value in having a BIM model with this augmented reality technology that you could disperse to your field people. Because we were on a job in Arkansas, and our prefabrication facility was in Kansas City. So it's not like there was a lot of communication between the two offices. And if you use a part wrong, you don't have it anymore, right? You have to wait for it to come back. I remember a lot of times we would just get frustrated and cut down some pipe, and then a couple weeks later realize that, oh no, we're out of pipe now, so we can't continue. We have to wait for another shipment from our facility. So that's really exciting to hear people are using the augmented reality.
Yeah, a lot of the bigger subcontractors now, like mechanical, they've been doing offsite, prefabrication for years.
Right.
But there's a lot of subcontractors now who are much more engaged, even electrical subcontractors, as you say, the larger ones, because it's less expensive, and you get more productivity if you've got people in a facility, so to speak, assembling things, than if they're out in the cold doing it. And if they can be outside and it's kind of a plug and play, doesn't mean that you've eliminated all of it, all of that outdoor work and so forth, but you've reduced it. So you're doing much more offsite prefabrication, tabletop. You have less injuries. Typically, if you're sharp, you can get with your insurance company, and you can get the rates reduced on your insurance, because fabricating offsite can be considered manufacturing, and that's a different insurance rate than on a construction site. So there are some things that are going on that way that people are starting to figure out and take advantage of, that they can only do really with some kind of a BIM model to know where the bends and everything's got to go in conduit. And in some cases they're running from box to box, so they'll prefabricate from box to box. They'll pull the wire so that when you get to the site, there really is hang the conduit, and the boxes are in place, the wires in place, and you're, hooking the wires together,
Yeah.
as opposed to bending and installing on site. Now that, our sprinkler fitters have been doing this for quite a long time, putting the embeds in, using GPS and other technology
Right.
to, using the BIM model to figure all that out, coming back after you pour the concrete to make sure the embeds didn't move too much. And, they're right on. I mean, they're super accurate. So they do a lot of the prefab off site. And I think that is one of the things that's really helpful. Another one that I learned while I was out visiting contractors that was kind of interesting is training. And one of the contractors, it was just really interesting. They said, we've got a labor shortage. And one of the challenges that we have is that we have a lot of labor, a lot of craft that really haven't ever installed what we're installing. Or maybe they're installing one material that butts up to another material and they've never done that before. They don't know what the details look like. And so they had BIM modelers who were designing all of the interconnections of dissimilar materials. And then what they would do is they would bring in the craft workers who are going to install it. And they would explode the model, they would put the model back together, they would rotate it, they would pull things apart, and after maybe 10 minutes, everybody that was going to install that would say, oh, I get that. I see how that goes together.
Right.
And so they were using it in a way to increase productivity over people standing there and going, well, how does this go together? And let's try this and then take it apart. It was, okay, we thought through this. We had one person who called the factory, to find out how this piece of glass all goes together, this glazing. How is the interface between it and the brick supposed to be? What are we supposed to do with all of the waterproofing and et cetera? And so that one person figured that out, modeled it, and then, showed all the craft. I was on a job and it was interesting how they were doing all of the coordination drawings and prefabbing. It was a big project. It was about $120 million project. And I said, boy, this sure seems like it takes a lot of time we've got a BIM modeler on site and he's coordinating with electrical, mechanical, and sprinkler and control systems and all that kind of stuff. And it just seems like, we've got a person here full-time doing this. And he says, well, number one, we would have to do it anyway. At some point we'd have to do it. But number two, he says, I've got a, just as an example, I got a mechanical contractor out here who told me he needs 10 people, 10 craft workers to get this job done in a normal situation. But he doesn't have 10 and he's not going to find 10. Right. They're just not out there. He can hire some people, but they're not going to be very productive or efficient. So he's got 7. And what that means is he can't have the normal situation where there's, hey, we got to go over and ask the electrician, where are you going to run your conduit? Or, hey, your conduit's in my way. I can't get my ductwork. He's from the day those 7 people show up to start installing, they have to be productive every day, all day. They can't have stops. They can't have things that are in their way. We can't be doing RFIs on, well, what do we do about this? Because now there's a beam in the way or something. We need all that resolved before we send the person over there to go to work. And so as long as those 7 people are fully productive, I can meet the schedule. But if they're not, then we're back to the old way we used to do things. And I need 10 people to get the same schedule done. So it's cut down the number of people. And, these are, to me, these are very practical ways. I mean, we're not using BIM in some kind of impractical, ethereal, hey, it looks cool, let's show the customer something nifty that we're doing. This is saving time, saving money. It's, being used for training, saving rework, using augmented reality to go look at an actual install to make sure that it matches the model. Right. All those things are just very practical uses of BIM that are being taken advantage of today. And I still feel like tip of the iceberg. I still feel like there's stuff that we're not fully using it, only in some ways because somebody hasn't dreamed up how to use it.
Right, exactly. Yeah, I mean, speaking to what you were just talking about, the practicality of it, I think being in VD&C the past, several years, the main thing I've run into is just, um, when I was at Swinnerton, I started the VD&C department in the Portland group, and one of the huge hurdles was just convincing everyone that there was value to it, right? Because people, the first couple of months I was there, people would come up to me and be like, "What do you do? What's going on? Why are we paying you?" But I remember the first project we delivered, we wrote over 100, maybe I think it was 120 RFIs in a 3-month period, right? And like you said, those RFIs would have been asked during production, during construction, or maybe even after the fact. So there's a lot of construction risk that you're mitigating up front by just having 1 or 2 people behind a computer instead of 4 or 5 carpenters or electricians or whomever out in the field trying to, working really long days trying to figure out problems on the fly. I think there's a lot of value for construction managers there. I think the other thing, the barrier that we're seeing, or that I've always seen, is just the education, right? I mean, I've had employers who just weren't willing to let me, train at technology on the job. A lot of the learning that I've had to do for VD&C has been off the clock on my own time. And so I think it's really valuable that, like BYU-Idaho is doing a degree in virtual design and construction is really valuable because, a lot of the other construction managers that I was working with, who had graduated, within the same time window that I had graduated, didn't even know what Revit was. They didn't know what Navisworks was. They'd never run into that at school or anywhere else. And so when they came out of school into a job, they didn't know how to do it, and the contractor wasn't going to pay for them to learn on the job. And so a lot of my peers in the construction industry just didn't get into it because it does take a long time to learn and become really good at. So I think it's very valuable that you're starting to teach it in school. I'll mention one other thing. The director of the Swinnerton Mass Timber, Christopher Evans, he had said several months ago, said that he wanted everybody to be able to open a Revit model and make a detail, or manipulate the BIM model in some way. Every project engineer, every project manager, every superintendent even. And one of the things that I was trying to explain was, that's not easy for people to learn. They're going to need some time to get acquainted with the software. And so I think another misconception in the industry is that these things are kind of simple or easy to learn, like kind of like on-screen takeoff is, or P6 scheduling. Not that those are simple applications, but they're much more easy to learn and get into than BIM. And I think for a lot of construction managers who aren't acquainted with VD&C, it's hard for them to see the value in it without having experienced it firsthand. So how do you?
I can tell you one really large, well, I shouldn't say they're really large, but they're big. They're a big contractor. They're in the billions. They're requiring every superintendent to know Navis and how to navigate within Navis. And so they're training them and they're teaching them because they absolutely see the value of a superintendent being able to come into the office, grab a pad and pull up a Navis model and be able to walk through, or to stand with their foreman or a subcontractor and walk them through. Here's where this stuff is going. Here's where these materials are, and so forth. So I think as time continues, we're going to see where it's going to become an essential element. I often thought that probably the most significant advance that construction made in the last 50, 100 years was CPM scheduling. It really was, it was the tool for a builder to think through a job, to sit down and really have to build it in your mind. That's what we do. In manufacturing, the way to become more efficient and more productive is to automate. And we may be able to automate some things some days because of BIM. I mean, I can definitely see automation as a result of BIM, but what we do to become more efficient at our craft is we plan. We have a really good plan. People don't get in each other's way. They're not, climbing on top of each other. You don't have 3 ladders, in the same space all at the same time kind of a thing. But, you really have to plan. Well, CPM forced us to do that. If you want to come up with a good schedule, you really have to think through the job. Well, now you can do even better. You can come up with a plan in BIM, and scheduling in BIM in the future, I think, is where the future of scheduling is that you're going to build the model on a computer, and you might have a VDC engineer, just like today we'll have somebody who's a planner and a scheduler. We'll have somebody who's really good at using the software. A superintendent will know enough to sit down and say, okay, I'm going to put these footings in, then we're going to do these, and then it's going to be this wall, and and this, and the scheduler is going to be a VDC engineer who's going to say, okay, these elements are going to be built this way. And then when you go out to the job site and you bring in a subcontractor, you bring in new craft, you sit down with them and you say, okay, here's what we're doing this week. Here it shows on the model, or here's where we're going this month. And you show them on the model, and it builds visually so that they're not looking at, a bar chart of 2,000 activities that fills up, 2 walls on a trailer that most craft can't. I'm not going to say they can't understand it, but they don't. It's overwhelming. There's just so much there. Whereas because we're very visual, it's a great technique for you to think through the job and to build the job and see if you've got any coordination issues. So, I think as time progresses, we'll see less and less barriers, and more people will just say, this is what we have to have. This is where we're going as an industry. And there's some companies that are already there, and they're just pulling us along.
Yeah. Well, what do you talked about automation. What do you say to construction managers who are worried about technology replacing, the human being, the carpenters, the electricians out in the field?
We're a long ways away from there. That's what I say. Like I said, as I started 25 years ago, we were doing 3-dimensional models. We could do walkthroughs. We could maybe not do quite what we can do today. We certainly couldn't do it as fast and as efficient as we could today.
Right.
But there could be some replacement of craft. And in that we have such a shortage of craft, with a 3-dimensional model of a building, you could come up with automation to do certain things inside the building. Now you have a model. Your program can understand where all the conduit is in the building, so to speak. Let's say we had a robot, and I don't want to think of like Terminator 2 kind of robot, but something that has some tracks and some arms, and does some things. It has a wire spool on it.
Yeah.
It has conduit it carries around with it, and you've got this building framed up. Well, now that you have a model, this robot, it knows where it's at. It knows how to get around. It knows where every box is going to go in the building. It knows how the conduit's going to go as long as it's been drawn. It knows which one's the home run. It knows where the panel is. It knows all those things. All you need to do is say, put this thing in the building, load up the wire on it, and turn it loose.
Yeah.
It knows where the stairway is, and it's not going to fall down the stairway because, it's already programmed to say, don't take stairs. Or maybe it does take stairs and it uses some different ways to do that. But, if you think about a simple residential house, it can hold up a box. It can nail a box on. It can drill holes in studs, and it can put wires through studs. It just needs to know where the boxes are, and with some basic programming.
Right.
So, we do have a craft shortage because construction, a lot of our youth are not allowed to work construction.
Right.
They, by law, they can't really work in the industry. So they've already been introduced to some other industry by the time they're of age that we can really put them to work. And so we have that to contend with. We have, young people who like computers and PlayStation, which I don't blame them, at all. It's fun. And so they want to go that direction. They've been introduced to that since, they were 10 or 12 years old. And so we have an uphill battle. Well, somehow we've got to confront that. I mean, we either have to allow our youth to work in our industry much earlier, or we're going to have to come up with some kind of automation for certain things, or the pay's got to get a lot better.
Yeah.
So that people go, hey, this is a really good job, and I can earn a nice middle income, doing this, and then they'll jump into it. So I do think, it could replace some positions, but we're not because every job is what we call a job shop. It's not manufacturing. Job shop basically just means each job is its own unique thing.
Yeah.
You've got a unique owner, you've got a unique engineer, unique architect, unique contractor, unique site, unique weather conditions. It's going to be hard to program something to take all those factors into consideration, because constructing is organic. It's people. People build stuff. Hammers don't build stuff. Material doesn't build stuff. And because people build stuff, even if we have robotics, it's a person who decides what they want in the building. It's a person who decides how big the building is.
Yeah.
It's a person at this point still who designs the building to meet what the customer wants, not what some program wants.
Right.
And so it's a very organic process, and we're always going to need people, I think, to interpret all of those nuances of the organic part of what we do to make sure the building is, at the end result, is what the customer wants.
Yeah, and I think that's true for every industry in a way. Even the industries like the automotive industry that has moved to a high degree of automation. It's people still want. Like I think of Tesla, right? You walk into a Tesla store, and as the customer, because Tesla has such a high degree of automation, they can afford to produce you a car that's a little bit more customized than some of the other automobile manufacturers. So it's almost as if the more you move toward automating the process of building something, the more human power you can put in the design, right? The cheaper, or not cheaper, but the more affordable customization really becomes, right? So anyway, I think that's a great note to leave on. Thank you so much for sitting down with us, Mike, and hope you have a happy holiday and keep working hard at BYU-Idaho. Do you have any other closing thoughts?
I think I exhausted my brain.
Okay. Okay, well, thanks everyone for joining us. We will see you next time as we talk about the role of technology in the construction industry. Thank you so much for watching our video today. If you would like to receive more of this content, feel free to like and subscribe. Also, please feel free to leave a comment below. We'll try to answer any questions or comments in our next video interview. Thank you. Bye.